We did these type of question in the last class, right? एक हफ्ते हो गए हैं class को, right? Last Wednesday we had a class. I hope you have done this.
Yes, sir.
Assalamualaikum Sarah, how are you?
Walaikum Assalam, sir. I'm fine. How are you?
I'm good. सारा पटना में ठंड आई है अभी या फिर अभी भी नहीं है?
थोड़ा बहुत है अभी।
थोड़ा बहुत है। जैसे रात में आप मतलब अगर निकलिएगा तो कुछ डाल के निकलते हैं या फिर ऐसे ही मतलब उतना नहीं है, चल जाता
नहीं,
काम बना
उतना
के?
नहीं।
Tomorrow I will be reaching Patna for the very first time.
Oh, nice. Why?
Why? I have a friend's wedding. I've gotten that. Send the answer on my WhatsApp, okay? Send the answers on my WhatsApp. Three more minutes, guys, okay? You had only 3 questions. Yes, Samiha, very good. All these three are correct. But exam में आपको ना वो reaction दिखाना पड़ेगा, like how are you going to prepare these alcohol from the alkenes given. So identification of alkene is one thing, but then you have to also show the reaction in the examination. Okay, so you just need to add
Like the
water in the.
mechanism?
No, not the mechanism. Mechanism नहीं लिखना है आपको.
Okay, so alkene plus H2O.
Alkene plus H2 in the presence of acid is going to give you alcohol. A simple basic reaction. Waiting for Fatima, Sara, and Wafia. सारा सही है, लेकिन एरो वो नहीं होगा. एरो ये वाला होगा ना, रेट्रोसिंथेटिक एरो. This one. Okay, you are going to use this one. Okay.
Okay, sir.
ये वाला प्रोडक्ट के लिए होता है. There are 8 types of arrows in chemistry. This is a retrosynthetic arrow. ये प्रोडक्ट वाला एरो होता है. What is this arrow used for? Tell me. ये किसके लिए यूज होता है? एक होता है एरो ये वाला. ये किसके लिए यूज होता है?
Equilibrium.
हाँ, what is to define? I mean, not actually equilibrium, लेकिन जैसे both forward and backward reaction both are possible, है ना. इस तरह से आपके पास एक और इस तरह का अगर होगा, ये equilibrium है, ठीक है, ये equilibrium है, लेकिन ये आपका ये भी it is like a forward reaction जा रहा है, लेकिन backward में भी कुछ reactions हो रहे हैं, है ना. Similarly, you can have the other way around, इस तरह से, ठीक है. Then you can have ये कर्व एरो मैकेनिज्म, इलेक्ट्रॉन का मूवमेंट दिखाने के लिए इसको यूज करते हैं, राइट. ये रेजोनेंस के लिए होता है, अगर आपको नहीं याद आया तो. दिस इज फॉर रेजोनेंस. देन वी हैव अ सिंगल हेडेड एरो आल्सो. करेक्ट, ये सुनो, है ना. सिंगल हेडेड एरो, एक इलेक्ट्रॉन का मूवमेंट. डबल हेडेड एरो, 2 इलेक्ट्रॉन का मूवमेंट. दिस इज इक्विलिब्रियम रिएक्शन. दिस इज इक्विलिब्रियम रिएक्शन, बट व्हिच इज प्रीडोमिनेंटली बैकवर्ड. इक्विलिब्रियम रिएक्शन, not equilibrium reaction, लेकिन reversible, sorry, reversible reaction is a better word. Reversible reaction, but it is dominant in the backward reaction is dominant. Reversible reaction, forward is dominant. Reversible reaction, like both forward and backward reactions are equally dominant. Resonance, products, retrosynthetic arrow. Who else has sent the answer? Okay. B1 is fine. I mean, I understand what you're trying to do, but again, B1 thoda sa you have to be careful, okay, how you're writing the answer. Otherwise, it is fine. I understand. A is correct, Fatima. B is also correct. C is also correct. Okay. So if I have these three, so this can be made by H plus and H2 will be there in all of these cases. A double bond will be here. For this, double bond CH2. Okay, Wafia. It is not like this. ऐसे मत बना दीजिएगा. It is 2 different bonds. If you're making it like this, okay, it should be like this and another parallel for a double bond. I need to stop sharing and re-share. Wait a second, guys. Now, for this also, I'm going to use the H plus and water. H plus and water will be used. Now, here we are going to have this one because I mean, either the OH will attach here or attach here. It is symmetrical. That is why we have given preference to this one. Okay. So we have a new student here. Hello, Assalamu alaikum, Sania. How are you?
I'm good, sir. Thank you.
Okay, Sania, which school are you from? Can you tell me?
I am from Royal Academy, Ajman.
You're from Royal Academy, Ajman. Ajman is in UAE, right?
Yes, sir.
How many chapters are done in your school? Is half yearly done in your school?
We just gave our term one recently. We have
Okay.
done 5 chapters.
Okay, you have done 5 chapters. What are those chapters?
Okay, solid state.
Solid state नहीं है syllabus में.
But we did that chapter.
Okay, but your board is CBSE, right?
Yes.
हाँ ठीक है. Solid state हटा दीजिए. What else?
Okay. Then solution chapter.
Solution is done.
Electrochemistry.
Electrochemistry is done. And
DNF blocks.
and
Haloarenes and the other one.
haloalkene and haloalene.
Yeah.
Right? And then 5th
And
chapter.
alcohol, ether.
This is done or
Phenol
going
and
on?
ether.
This is done
It's
or
done.
going on?
It's done.
Okay, fine. Okay. So we have completed solutions, electrochemistry, haloalkene, alcohol is going on. Okay. And we
Okay.
have completed chemical kinetics.
Okay.
Okay, we have completed chemical kinetics. So these are the chapters which are done. Okay. And DNF block, I mean, I have not done this in our class, but I have taken some extra classes for it. But again, I'm going to teach DNF block in the regular classes also. We have not done DNF block. Alcohol, phenol, and ether is going on. And how was your half yearly, Sania?
It was good, sir. But we had some consequences, like, because most of the teachers in our school, they left. So we had some problems coping up with the subjects.
Oh, okay, fine.
Mm.
But you're okay with these chapters though? Are you having?
Yes, sir.
Okay, you're okay with these chapters. So I think you can pick up from alcohols, like whatever we are doing right now, correct?
Yes, sir.
Okay, fine. We're just doing the preparation of alcohols right now. Okay. So we have done a few preparations. Okay. And right, guys, the next one, I think how many we have done? I think we have done 6 or so. Hydroboration, oxidation. Alcohol was, alkene was 6, right? The last one for alcohols, 7th. From aliphatic, where are you originally from? Yes, Sania.
India, sir.
Where in India?
Goa.
Oh, Goa.
Yes, sir.
Like Goa, or like your parents are from somewhere else?
No, I was born in Goa and my parents are also from Goa.
Oh, your parents were also. Okay, nice. Please write. When amines react with nitrous acid. Okay, do you have a chemistry teacher right now in your school?
Yes, sir, we do have a chemistry teacher.
Which chapter is going on in your school?
Right now, we just finished our one, so a new chapter is going to start.
But you have no idea about what the chapter is going to be.
No, I don't have idea. Sorry.
Okay, no problem. Okay, please write when amines react with nitrous acid. What is nitrous acid? It is ONO. It is ONO. When it reacts with ONO, it leads to formation of alcohol. Okay, it's a very simple reaction. We will take any RCH2 NH2, that means a primary amine CH2 NH2, and we are going to react this with nitrous acid Oh no. And it is going to give me alcohol RCH2. NH2 will be replaced by OH. We'll also get nitrogen gas and water molecule. Just to have an idea how this reaction happens. So we have this substrate that is RCH2 NH2. I'm going to write the hydrogens like this, okay? Now, here what happens? OH attaches with carbon atom, the nitrogen attaches with the nitrogen atom, and the oxygen attaches with both of these hydrogen atom. Okay, this is your ONO, and it leads to formation of what? As you can see, it gives three things, right? RCH2OH, okay, and it also gives what? It also gives you nitrogen, and it also gives you what? It also gives you the water molecules H2O, right? So I hope you can see that this reaction will give you alcohol, nitrogen gas, and water. Alcohol is the most important thing that you have to remember. Okay, we can write some more examples. You just need to replace the NH2 with OH. Okay. Wherever you find NH2, the reagent is ONO, HONO. We are going to replace the NH2 with OH. But please remember, it is only going to happen with aliphatic amine, not aromatic amines. Okay, so this is cyclohexane, not benzene. That is where this reaction can happen, and it will give you cyclohexanol. You can also have it a 5-membered ring. And why are you late, Sanya? You're late a bit. Why is that?
Sir, here actually it's prayer time, so I was praying.
Okay, okay. It's Maghrib right now?
Yes, sir.
Okay. You're okay with this bond line structures, Sanya?
Yes, sir.
How many carbons are here in this one?
2 carbon.
This one, see? First carbon is here, second carbon is here, and the third carbon is here. There are how many carbons, Tanya?
3.
Okay. Now the first carbon has how many hydrogens?
3.
Very
No,
good.
wait, 4. 3, yeah.
3, no? Because one
Yeah,
bond is already there.
CH3. Yeah.
Yes. Second one will have how many hydrogens?
CH2.
No. See, the second one already has how many bonds? Can you see in the second one? Tell me.
1, 2, 3 bonds.
3 bonds are there, right? And carbon can make how many maximum bonds?
4.
So 4 minus the number of bond already present is equal to 1. So 1 hydrogen is there, which we have not
Okay.
shown. Got it?
Yes, sir.
Okay. Tell me for this one, this red one, how many hydrogens will be there?
1.
Very good one. Is everyone done?
Yes, sir.
Is there anyone who's still writing? No. Okay. Okay. Please write. Methods of Methods of preparation of phenol. Method of preparation of phenol. So we just completed method of preparation of alcohols. Now we are going to look at the method of preparation of phenols. Please write number 1. From benzene sulfonic acid, Let's look at the reaction first. Now we'll start with benzene, not benzene sulfonic acid. See, we have benzene and we will do sulfonation to benzene. The reagent for sulfonation to benzene is what? Concentrated H2SO4. For sulfonation of anything, what is the reagent? Concentrated H2SO4. And you will also see SO3 gas. Whenever you have H2SO4, there will be SO3 gas always present. This is going to give you a SO3H group on the benzene ring. Okay. Now, then we do a reaction with NaOH, sodium hydroxide. At high temperature, almost 623 Kelvin, and high pressure. This replaces the SO3H with ONA. Why we have ONA? Because we are in the basic condition. Now we have ONA, we want to replace this Na with H+. So we'll add H+, any mineral acid that is going to give you protons. In the presence of water, we are going to get phenol. Please write. Sulfonation of benzene with oleum. What is oleum? Oleum is nothing. It is H2SO4 sulfuric acid plus SO3 gas. Okay, SO3 gas gives benzene. It gives benzene sulfonic acid and on further treatment with sodium hydroxide at high temperature. रजान, ये क्या बात है? आके बस आप बैठ गए ना, सलाम ना कलाम ना कुछ नहीं. हाँ, high temperature and pressure. Razan, why are you late?
Assalamualaikum, sir.
Walaikum
Sir,
assalam.
I woke up late.
Sorry,
I
you
woke
woke
up
up
late.
now? What are you saying? You woke up now?
Yes, sir, I woke up late.
अच्छा ठीक है सॉरी. अच्छा वहां तो दोपहर हो रही है. ओके ओके. I was like ये तो मतलब अब तो सोने जाने का टाइम है. It's 9 o'clock here. Oh okay. अब नींद पे आदमी ना कुछ नहीं बोल सकता है. Like for example, if you're sleeping and you miss the prayer, then that is a valid reason to miss a prayer. But again, as soon as you wake up, you have to make up for that prayer. But सोने पे आदमी क्या बोल सकता है ना? It's fine. Treatment with NaOH and high temperature at high temperature and high pressure. I missed this word of high. High temperature and high pressure gives sodium phenoxide ion, which on acidic hydrolysis gives phenol. It is going to give you phenol. All of you wrote this, yes or no, please tell me.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Right, next. Second one. From benzene, diazonium salt. From benzene diazonium salt. Please write. When benzene diazonium salt BDS is treated with BTS नहीं है ये BDS है ठीक है is heated with or rather is like heated in the presence of water, phenol is formed. Okay, how do we get benzene diazonium salt? Again, we require ono for that. Okay, we have a benzene ring on which you have to attach NH2. So we have got aniline. From aniline, we are going to get benzene diazonium salt. How? We will get ono. Ono is formed when you react NaNO2 in the presence of HCl. This is going to give you what? Ono at 0 to 5 degrees Celsius because ono is very reactive. So you have to keep the temperature low when we are preparing ono. And this is going to give you benzene diazo. This will be N2 plus and Cl negative benzene diazonium salt. And specifically speaking, this is benzene diazonium chloride. When I just keep water in the presence of benzene diazonium chloride, it is going to give me phenol. Benzene ring with a OH group like this, as simple as that. What was the reagent in the last reaction? The last reaction, the reagent was benzene sulfonic acid, and then we used NaOH. In this, we are using H2O. With the third one, Dawes process. Dawes process. All of you wrote this now? Yes or no? Please tell me. Reaction लिख लिया सबने?
Yes, sir.
Yes, sir.
We have already seen Dawes process in the chapter haloalkene halorine. So we start with haloarine. And specifically speaking, we start with chlorobenzene and we react this with sodium hydroxide. Now, the nucleophilic substitution of haloarine is not possible at room temperature, at normal conditions. So drastic condition is needed. That means around 623 Kelvin of temperature, 300 atm of pressure. And we also use copper salt as a catalyst. Okay, this copper salt is only the extra thing that you have to remember. This is going to give you, now again, please see, since this is in basic medium, I will get benzene ring, ONA, sodium phenoxide ion. And in the presence of H plus and water, it is going to give you phenol. Okay, please write. Phenol is commercially prepared by heating chlorobenzene with sodium hydroxide and copper salts at 623 Kelvin and 300 atm pressure. To form, what do we form? Sodium phenoxide. To form sodium phenoxide, which on acidic hydrolysis gives phenol. Okay, so this is the second equation in which we are using sodium hydroxide, and then we have to do acidic hydrolysis. Is everyone done? Yes or no? Please tell me. Is everyone done?
Done, sir.
Done. Okay. Write the last one. Okay. Last one for the preparation of phenol is right from cumene. Thank you. So in cumene, we start with a benzene ring, and this benzene ring has isopropyl group here. Okay. Isopropyl group. What is isopropyl group? We have CH. The CH has one CH3 and another CH3. This is isopropyl group. Now we oxidize it just in the presence of air. Look at these reagents. Okay, look at these reagents. Oxygen, okay, oxygen, O2. Now what it is going to do, it is going to insert the oxygen into this C and H bond. So we had this carbon atom, it had a CH3 group attached to it, it had a CH3 group attached to it. Now the CH bond will have two oxygen attached in between like this, and then the hydrogen. Okay, the benzene rings as it is. Now, if you are going to do acidic hydrolysis, we get phenol. Okay, so complete migration happens here. Actually, this complete thing, it moves here like this, and this complete thing, it breaks and it gives the electrons here. And when it is giving electron here, you can see that what we are going to form, we are going to form CH3. Then we have carbon, and this carbon already had one CH3. Now it had one bond with oxygen atom. Now that bond has got double bond. So we have also got a double bond here. Okay, now we get phenol as well as acetone.
So can
A
you
very little amount. Sorry?
Can you explain this reaction once again?
Yeah, sure. So see, when we are going to add H plus in this case, this carbon atom, it is attached with oxygen. This oxygen is further attached with oxygen. That means this carbon atom will be what? It will be highly polarized, delta, positive sign will be there. Okay. And also please see, what is the shape of this particular cumene molecule? It is something like this: carbon, CH3, CH3. Okay, then we have oxygen atom, and then this oxygen is going to have a bent structure. Enough. अगर याद कीजिए आप लोग molecular structure, it is not going to be linear, right? It is going to be bent. O, and then this again, O is going to be bent with a hydrogen here. Now this particular lone pair electron can easily attack on this carbon atom. This carbon atom has a very high delta positive because this is having an oxygen further attached to oxygen. Okay. Just a second. So this oxygen, it attacks onto here. It migrates because this bond breaks, this migrates, and we get OH bond. And this bond, it breaks and it gives you a double bond with carbon atom. So this OH is migrating here, and this carbon atom C single bond C is going to break, and it is forming acetone reaction. It is going to form acetone as a product. So the important thing is that we are using a very cheap oxidizing agent, that is O2. O2 is very cheaply available. Then we use a very minute amount of mineral acid and water. So this overall reaction is very cheap and we get very important product. We get phenol as a product as well as acetone. Phenol is synthetically very important for the formation of many compounds. Acetone is used as a solvent. So acetone is also very useful. Okay, we will please write here when cumene reacts with O2 from air, cumene hyperoxide is formed, and on further hydrolysis it forms phenol and acetone. Is everyone done? Yes or no, please tell me.
Yes, sir.
Okay. Sometimes they will ask you this, please write, give reagents for following. Give reagents for following. Please see, guys. We start with benzene. And from benzene, we have to prepare cumene. CH3 and another CH3. This is cumene. Okay. Then from cumene, you have to form phenol. Okay. Why are they asking this question? Because this is 12th class and this reaction is from 11th class. Because see, benzene reaction we have seen in 11th standard, right? We have a benzene reaction. We are dealing with functional group now. So benzene reaction we have seen. What we are going to do, we are going to add an alkyl group here. So if I want to add an alkyl group, please remember Friedel-Crafts alkylation. In Friedel-Crafts alkylation, whatever alkyl group you have to add, please make that alkyl group. This is the alkyl group I have to add. And the point of attachment is the second carbon. On the second carbon, you are going to add a chlorine atom. And you're also going to give a Lewis acid AlCl3 for the reaction. I hope now this reaction is quite recognizable to you. Okay, now cumene to phenol, we have just seen. First step will be O2. Second step is going to be water in the presence of H+. These are the two reagents you have to add for the formation of phenol from cumene. Okay, please write this, guys. Also, I will end this class in 1 hour only. Okay. I have to pack some stuff and I have to leave in the morning. Write this and then I will discuss physical properties of alcohols and phenols both. All of you wrote this, yes or no? Reagents for the following?
Yes, sir.
Yes.
Right, physical properties of alcohols and phenols. Okay, number one. Physical state. Please write lower members of alcohols lower members of alcohols are colorless liquid. Are colorless liquid with characteristic smell. Next, alcohols with more than 12 carbon. Alcohols with more than 12 carbons are colorless solid. Are colorless solids. Right, next, about phenol. Phenol are crystalline. Phenol are crystalline solid or liquid. It depends on how you are preparing the phenol. If you give it adequate environment, it is going to crystallize itself and it is going to get into solid state. Otherwise, it is going to be in liquid state. Okay, so you will either have crystalline solid or it will be liquid and have phenolic smell. Okay, this is a very small point. Right, next, which is more important, second one. Since most of the alcohols are what? The lower alcohols are liquid, we are going to talk about the boiling point. Right, next one. Second part is boiling point. Okay. In boiling point, please write boiling point of alcohols. Boiling point of alcohols increases with increase in number of carbon atom due to increase in molecular mass, which leads to increase in van der Waals attraction. Which leads to increase in van der Waals attraction. Okay, that means if I talk about very lower alcohol, CH3OH, this is going to have lower boiling point than alcohols with 2 carbon atoms. It is going to have lower than 3 carbon atoms. It is going to have lower than 4 carbon atoms. It is going to have lower than 5 carbon atoms. Okay, and so on. Okay, and so on. Right, next, boiling point of alcohol decreases with increase in branching. decreases with increase in branching. So if I have 4 carbon atoms and then a OH group, this is a linear, this is a chain. Okay. Then we have, this will be having highest boiling point than if I have one branch. It will be what? Higher than if I have multiple branch like this. Okay. Why is this like this? The reason is that, see, if I'm going to make a dipole, this dipole is going to be large, this dipole is going to be small. It will also have some kind of cancellation of the dipole moment, because this carbon atom will be what? Having some more, it will be more electronegative because it is attached to OH group. Okay. And here you can say that you have very small dipole moment. Okay. The dipole moment is going to decrease when you are going to increase the branching, and that is why the boiling point of alcohol also decreases. Right, next. This is an important point. Boiling point of alcohols and phenols are higher than hydrocarbons. That means alkane, alkene, alkyne. Okay, all of these hydrocarbons will be having lower boiling point than the alcohols. Haloalkanes. Okay, so they will also have lower boiling point than alcohols. Haloarenes and ethers of comparable molar mass. Okay, so if comparable molar mass, that means the molecular mass of those things, whatever you are comparing the boiling point of, should be similar. Okay, because if you take a very huge difference in the molar masses, then the functional group will not be a dominant factor in the determination of boiling point. The molar mass will become the dominant factor in the determination of boiling point. So whenever we are comparing which functional group is going to have higher boiling point, we take the molar masses as to be similar. Okay, right, next. Now, why is this? Why is alcohol and phenol having higher boiling point? This is because any idea why is this? This is because alcohols and phenols can form intermolecular hydrogen bond. Intermolecular hydrogen bonds, which increases the intermolecular force of attraction, and hence the boiling point increases. Okay, so the alcohols, they have ROH. Okay, so we have ROH, and then you're going to have, let's suppose, something like this. So this oxygen and this hydrogen, they are going to form hydrogen bond. This and this is going to form hydrogen bond. Okay, please remember, isko hydrogen bond nahi bolte. This is a covalent bond. Hydrogen bond is formed between the oxygen of one atom, oxygen of one molecule, and the hydrogen of another molecule. Okay, so these are the hydrogen bond. Okay, this is the hydrogen bond. Right, next. See, if I'm going to compare, this is alkene. Then we have RCl. Then you can take RBr, and then you take ROH. First of all, you categorize them in what kind of intermolecular force of attraction they have, or what kind of molecules these are. So this is what? This is only having van der Waals force because it is non-polar. This is non-polar. Both of these are what? Polar, because Br is more electronegative, Cl is more electronegative. It's going to have delta positive and delta negative charges. So these are what? Polar molecules. Okay, and then this is what? This is a case in which whenever you have a hydrogen bonded either with fluorine or nitrogen or oxygen, then this is going to form what? Hydrogen bond. So as you see, OH, oxygen bonded to hydrogen, these molecules are going to form hydrogen bond. Okay, so this is hydrogen bonded molecule. The force of attraction in non-polar is van der Waals. In polar, it is dipole, attraction, and hydrogen bond, it is hydrogen bonding. So obviously, hydrogen bonding is having higher force of attraction than dipole, and then van der Waals. And that is why, if I take this case, and let us say this is A, this is B, this is C, and this is D. Okay, in this case, B will be having the highest boiling point, followed by, now RCl and RBr. Here you can see that Br is going to have a very high molar mass, right? That is why you are going to say, what is going to be there? You are going to have Br, that is C, and then B, and then A. Okay. So the boiling point will be something like this. Write this down. Then everyone, yes or no, please tell me.
Done, sir.
Okay, right, next. We have a case in which we are going to take ether, CH3, oxygen molecule, oxygen atom, and CH3. Okay. Now please see at ether molecule. Ether molecule, this will be what? Delta positive, delta negative, and this will be delta positive. So you can see the dipole moment will be like this and like this. Right? So both of these dipoles are in different directions. So net effect will be what? It will be non-polar. Okay, or rather I can say very slightly polar it will be, right? Okay, it will be non-polar, or you can say very slightly polar, because oxygen molecule, it has kind of structure like this, not completely linear. So it will be slightly polar, I can write. Okay, if you want to write, you can write slightly polar. And if you compare CH3, CH2OH, as you can see, the molar masses are comparable. This is having hydrogen bond. So obviously alcohol is going to be having more boiling point. Similarly, if you take benzene, this will have lower boiling point than any haloarine, and this haloarine will have lower boiling point than phenol. Once you're done, you will write a question, and then we will be done with the class. Please write, arrange the following. In decreasing order. In decreasing order of boiling point. All of you wrote all of these examples, yes or no? Please tell me.
Yes.
All of you? Okay. Right now, arrange the following in decreasing order of boiling point. The first one that we have is 1, 2, 3, 4. And then we have a OH atom here. The B structure is Oh, sorry, just a second. नाम दिया हुआ है. Please write pentane 1-ol. B is N-butane. C is pentanal. And D is ethoxyethane. Okay, so pentanal, 5 carbons. 5 carbons means 2 hills. Okay, 2 hills will give you 5 carbons. 3 hills will give you 7 carbons. Okay, and then OH. This is my A structure. D is N-butane, normal butane, 4 carbon atoms. Okay, that means 4 carbon atoms without any branches, normal butane. Then we have pentanal. So 5 carbon atoms, 1, 2, 3, 4, 5. And this 5th carbon atom is going to have a aldehyde group, double bond O and a hydrogen atom here. Ethoxyethane is very simple. You have 2 carbons here. It is attached with oxygen. This oxygen is further attached with to another carbon atom. Okay. So the forces of attraction, or I can say you can categorize this molecule into what categories? Either it will be H bonded, or it will be polar, or it will be non-polar. Okay, or it will be non-polar. So first of all, tell me, please don't write now. Tell me, this is what hydrogen bonded, polar or non-polar? Pentane 1-ol. Tell me, guys.
H bond.
Yeah, correct. This is going to have hydrogen bond. Very good, guys. Butane is what? Polar, non-polar, hydrogen bonded. देखिए, if you don't see anything, it is going to be non-polar. Okay. For hydrogen bonded, what you have to see, hydrogen is either bonded to fluorine, directly bonded to fluorine, or oxygen or nitrogen. ठीक है? Polar में आपको क्या देखना पड़ेगा? Polar में you have to see carbon is bonded to any electronegative element. Okay, any electronegative element. Tell me, non-polar में it will be plain and simple. Carbon carbon का bond है, carbon hydrogen का bond है, nothing else. And butane, tell me, hydrogen bond, polar or non-polar?
Non-polar.
Non-polar.
Non-polar. What about this one, pentanal? It is going to be
Polar.
very good, polar. Ethoxyethane is going to be
Polar.
yeah, polar, but it will be what? Slightly polar, right? Because देखिए यहाँ से आपके पास the delta negative आपको भी बताया था हम लोगों ने ना, we just saw ना, all the ethers are going to be slightly polar, or eventually this will be non-polar. Why this will be non-polar? Because the structure will be very much towards the linear structure, because we have a bulky group here, we have a bulky group here. They are going to repel each other and they are going to straight themselves up. Okay, so I am going to write here non-polar. Okay, I'm going to write here non-polar. Now, what will be having, which one will be having the highest boiling point? Obviously, A is going to have the highest boiling point, followed by C. Now, this is also non-polar, and this ethoxyethane is also non-polar. But as you can see, here we are having 4 carbon atoms. Okay, here we are having 4 carbon atoms. Here we are having 4 carbon plus 1 oxygen. Okay, 4 carbon plus 1 oxygen. So whose molar mass will be higher, B or D? Which will be having higher molar mass? Tell me.
D.
Which will be having, D will be having higher molar mass now, because 4 carbon and 1 oxygen. So jiska zyada mass, that is going to be your having higher boiling point, followed by B. Okay, when we are comparing this, this is decided by molecular weight. Done everyone, is please tell me. जल्दी लिखिए इसको.